Hello everyone. First of all, thanks to Emertxe Information Technology for providing embedded system internship. The project which I was done is washing machine simulator using PIC16F8778 microcontroller. Before getting onto the project, let's have a look onto the content. What I learned in this internship, introduction to the project, peripherals of project demo video finally. And let me give you a brief introduction about the company. Emertxe. I'm very thankful to Emertxe Information Technologies for guiding throughout my internship. Emertxe is India's #1 training institute for freshers to pursue a career in core embedded systems and IoT. And then and then what I learned in this internship. First of all, embedded system is a combination of software and hardware to do a particular task. For example, software means here we are using a different software languages like C programming. Here the high degree of portability offered by C programming is the reason why we are using in this embedded system. C programming language has the high degree of portability. Due to that, we are using this in embedded system. And C is a general purpose procedural high level programming language used in the development of computer software and applications, system programming, games, and more. And C is also used in firmware, middleware, and driver development. And C is one of the most widely used programming language. And also it is used in system software development, and also it is used in embedded system software development. And the main thing is C utilizes very less time required for execution and space required is small. And also efficiency and portability are the important considerations of C programming to use in embedded systems. And also library facilities play an important role in C programming. But every language has library facilities. In that also library facilities play an important role in the C programming. And also it has some important characteristics. Those are general purpose language, and also it is a free formatted language, and also it is effectively used in various specific domains. Why should we learn C? Coming on to the why should we learn C? C was the basic language for any other languages like PHP, JavaScript, and Java. And also C helps to understand a lot of underlying architecture of the operating systems like pointers working with memory locations. And now coming into the main topic of ours is embedded systems. Embedded systems. An embedded system is a combination of hardware and software designed which is intended to perform a specific task. Embedded system may also function within a large system. The system can be programmable or have a fixed functionality. And also the microcontroller based control system. It is embedded system is a microcontroller based control system used to perform specific tasks for, for operations. And then there are some of the embedded system components. Those are those components are microcontroller, system on chip, or microprocessor. These are the main main processing units of the embedded system. And then we have memory, FPGA or ASIC, diagnostic port, human interfaces, ADC, DAC, actuators, sensors, auxiliary system. Here microcontroller or SoC microprocessor was the processing unit of the system. And then coming to the auxiliary system, it provides power for the system, and then it cools because of semiconductor devices have more heat generation, so that's why burning effect can be made. To cool down that, we are using auxiliary system for cooling purpose. And also actuators are based on the sensors. And also ADC, analog to digital converters, DAC, digital to analog converters. And here there are human interfaces. Interfaces can be Human interfaces are also two types: interfaces and output interfaces. Input interfaces are switches, touch sensing screens, microphones, and also output side we have some interfaces like CLCD, that means character liquid crystal display, and the 7 segment display and LEDs. These are output interfaces. And then diagnostic port to fault analyze. This was the main important peripheral in the embedded system component to to analyze the faults in the system, so that it keeps monitoring the system very rapidly. Memories, it have two types of memories: RAM and ROM. RAM, random access memory, it can read or write the memory. ROM, random read only memory, it only reads the data, it not writes the data. And then FPGA or ASIC, field programmable gate array. And then coming to the some of the examples of embedded systems, those are microwave oven, washing machine, routers, CC cameras, refrigerators, and then DVD players, routers, mobile phones. These all are the examples of embedded systems which we are using nowadays. This was the Tesla car, and these are the examples. And then coming to the some of the categories of the embedded system, there are four types: standard, standalone, real time, network embedded system, mobile embedded system. Standalone embedded system, standalone embedded system means it takes its own decisions. That means embedded system can take its own decision. For example, Tesla car, we have Tesla car. This Tesla car can operate on its own decisions. Real time embedded system, embedded system takes action within the deadline time, that means specified amount of time. For example, airbag system, pacemaker, missile systems are the examples of this. And the network embedded system, which can connect to other devices and able to transmit data and then receive data. For example, these are the examples: drone, routers. And then mobile embedded system, carried from one place to another. And then microcontroller, all the components are integrated in a single chip to perform a specific task. Here, all the components are connected like peripherals, CPU, RAM, ROM, ports, time, and CPU is the heart of the microcontroller. And then it has memory size, input output capabilities, peripheral functions. IO capable input output pins are fixed in this microcontroller, and all components are present in single chip, and it also has less flexible, less design complexity. And then coming to microprocessor, microprocessor is an important part of a computer architecture, without which you will not be able to perform anything on your computer. Micro in microprocessor, all the peripherals are separately integrated, so that it has more flexibility to to perform any task. These are the differences between microcontroller and microprocessor. Microcontroller has components in single chip, and whereas microprocessor has all separate components. So that microcontroller has less flexible and less design complexity. Microprocessor has more flexible and more design complexity. This was the topic about the microcontroller and microprocessor, and then C programming, and then embedded system. Now coming to the introduction to the project. What is the project? I was working on the project that is automatic washing machine simulation. Washing machines are the devices which are used for cleaning of the clothes without a person. And also washing machine reduces the human labor. So that nowadays almost all every house has these washing machines. And also the nowadays automatic washing machines are developed to increase the nowadays customers utilization. And then software required for this project are MPLAB XID and X8 compiler, and then picsimlab. MPLab X ID. MPLab X Integrated Development Environment is a software program that runs on your computer to develop applications for microchip PIC microcontrollers. And then Xe8 compiler. It is a 8-bit PIC devices, and also it is a C compiler which is used to compile the code, and it has some standards and pro editions, and also to reduce code size and are not necessary for our purpose. And then picsimlab. Picsimlab is a real-time emulator of development boards. It simulates the code which was working, what are we doing, what we are doing. And then picsimlab supports microcontroller from picsim, simaware, ucsim, and then gpsim. These diagrams shows the picsimlab PicGenius PIC16F8778 microcontroller. In this there are 16 switches, LEDs. This represents CLCD. This represents 7-segment display, cooler, heater, buzzer, and then reset option we have. And then coming to the peripherals of the project. What are the peripherals we are using in this project are switches, LEDs, timers, CLCD, buzzer, fan, PicGenius, PIC16, F8778. PicGenius is the board what we are using, and then PIC16 F8778 is the microcontroller which is used in PicGenius to perform washing machine operation. And then coming to the now important peripheral of the project, PIC16F8778. It is one of the most renowned microcontroller in the industry. It is very convenient to use and code, and also it has the many advantages, and it performs write erase as many times as possible because it is a flash memory technology, and it has total 40 pins. Those are 33 pins for input and output, and then it has fixed number of input output ports, and also 8-bit data bus. It has 8-bit data bus. There are some ports: port A, port B, port C, port D, port E. Port A has 6 pins, port B has 8 pins, port C has 8 pins, port D has 8 pins, port E has 3 pins. Altogether combined 33 input output pins are there for 5 ports, total 5 ports. Therefore, PIC16F8778 is a 5 port, 33 input output pins, and then LEDs are connected to the port B and port D. Next, coming to CLCD. CLCD represent character liquid crystal display, and also it has 16 pins, and also it is a variant of LCD. Only we can display all characters of ASCII characters, and it has different variants like a 16 cross 2, 16 cross 4, 16 cross 1. Here 16 represents the 16 columns 2 rows, 16 columns 4 rows, and then it has 16 interfacing lines, 16 pins. Those are VSS, VDD, anode and cathode pins, and then D0 to D7 for data transfer level, and then RS, register select. If RS value is 1 means it identifies data. If RS value 0 means it identifies instruction, clear screen. And then it also has enable pin, EN. If enable pin equal to 1 means it enables the CLCD. If enable pin equals to 0 means it disables the CLCD. And also it has one more pin like called R/W bar, read or write bar. If R/W bar equals to 1 means here the read operation was performed. If the R/W bar means 0 means here write operation will perform. And always this is connected to microcontroller, and also microcontroller always writing to the CLD. And also it also has two type modes, 8-bit mode and 4-bit mode. Whereas in 8-bit mode D0 to D7 lines are connected, whereas in 4-bit mode only 4 lines are connected. And then coming to tactile switch. Here the switch is connected to the microcontroller. How it connected? Therefore, he the designing pull down interface must be R1 is greater than 10 R2, and it also has two methods: edge triggering and level triggering. Edge triggering means for one time task, and level triggering for continuous tasks. For example, we have to do continuous task means we can use edge triggering. Level triggering, sorry, for example, we want to do one time task means edge triggering. For continuous task means we use level triggering, where the switches are connected. Here the switches are connected, and we also have the bouncing effect here. This bouncing effect is is a metal plate and terminal spurious pulse detection. While pressing or releasing, the tactile switch is called bouncing effect. Pressing and releasing is called bouncing effect. And then here we have six switches: RB0 to RB5, pull up circuit. And then coming to timers. In this timer we have three modes: timer 0, timer 1, and timer 2. Timer 2 those are also called as PWM or pulse generator or counter, or PW or PP measurement. And also timers are going to store the count in timer register, or to calculate or track the time, or it is a default peripheral of microcontroller. And it is also a 8-bit register. TMR 0 is a 8 timer 0 is a 8-bit register. And it has some considerations like tick. Tick means out up count or down count, up tick or down count, anything. One increment is called one tick. And then quantum, time taken by one tick. System clock setting depends on the system clock setting. uh, and also time is the reciprocal of frequency. Quantum depends on the tick. And then coming to scaling, pre or post scaling. And then resolution, it represents the width of the register. That means if it has 8-bit register means, then width of the register means 8. And then going to the output screen. Here we have output screens like power on screen to display, to on the washing machine. And then washing program screens. In this washing program screens we have different types like daily, heavy, and then woolen clothes, and then automatic, auto, aqua store, and then etc. And then water level screen, it represents the water level of the washing machine like auto, maximum, high. And then start screen to start the operation. Function screen, here the function, that means timer, up down, here the timer means down counting can be done here. And then completion status screen means program completed, remove clothes, it represents. And then there are some advantages and disadvantages on washing machine based on washing machine. These are the advantages: it requires less time, less water consumption, automatic cleaning, and then easy to use, and it has great capacity. There are also some disadvantages like cost is more, high price, electricity consumption. More electricity can be consumed, and then high price, cost is more based on the peripherals we are using. That means if it is a semi automatic or a fully automatic, or there are different types. Based on those, it has prices. And then working and project demo. Here we are using a MPLAB XID for code. This was the code. These are the washing programs: daily, heavy, delicates, white, stain wash, eco cotton, woolens, and then bed sheets, rinse, dry, wash only, dry only, aqua store. These are the washing programs. And then water level: auto, low, medium, high, max. First of all, we are powering on the washing machine, and then powering on washing machine, and then washing programs, and then And if function timer starts here, the down counting was happen. And then finally program completed, remove clothes. This was the program. And then we are going to clean and build the code. Clean and build. Yeah, it's cleaning and building the code. Yeah, clean successful. Yeah, build successful. So now we move on to the picsimlab app and then run the code, load the hex file. Here loading. This was the PicGenius PIC 16 F8778 microcontroller. This was the picsimlab software. Here we can select the board, that is PicGenius we are using, and then microcontroller PIC 16 F877A. And then load the hex file. Load hex. Automatic.x production. Press key 5 to power on the washing machine. Here it represents powering on washing machine. Again press key 5 and then we move on to the, there are washing programs. Here it displays washing programs, daily, heavy, delicate. To navigate all the washing programs, press key 4, that is RB3, daily, heavy, delicates, whites, stain wash, eco cotton, woolen, bed sheets, rinse plus dry, and then dry only, wash only, aqua store, daily. Now for water level screen, long press the RB3 switch, that means 4, switch 4. By long pressing the RB3 switch, we can navigate to the water level screen. Here there are auto, low, medium, and here it represents water level screen. In this, to navigate the water level options, we need to click on RB3, auto, low, medium, high, max, and then coming to auto. To start the function, long press the RB3 switch for. Here key 5 to start the operation, key 6 to stop the operation. To start the washing machine or to stop the washing machine. Let's switch. Let's press the switch 4, switch 5, that is RB4, to start the washing machine. Here the washing machine started programming function. If we press the RB5 means it passed the washing machine operation for some time. After starting the, it continues. There are three options, and that those are wash, rinse, spin. Wash completed, rinse completed, and then finally spin. Yeah, program was completed. So finally, washing machine operation was finally completed. This was the project demo completely. Coming to the conclusion, the washing machine simulation using picsimlab served as an effective tool for learning and applying concepts in embedded system. I learned hands-on experience that completed theoretical knowledge and provided a foundation for further exploration in the field of automation and control systems. Thank you for giving this opportunity for embedded system internship of Emertxe information technology. Thank you so much. Thank you.